Have you ever encountered this situation? You know what you're looking for, but you just don't know what words to use to search for it. For example, you want to search for ways to treat a cold, but in fact, using specific symptoms like reduce fever or relieve cough might help you find more useful information. Today, let's talk about a technology that makes AI search understand you better in the latest research. Researchers found that combining traditional query expansion techniques with large language models, LLM, can improve search effectiveness by 1 to 6 percentage points. This discovery comes from the latest research released by Gina AI. Let's slowly understand what query expansion is. This concept is actually easy to understand, and we can explain it through a daily example. Suppose you want to search for information about coronavirus. In traditional searches, the system only looked for documents containing the word coronavirus. But with query expansion, the system automatically adds some related terms for you, such as COVID-19, SARS-CoV-2, severe acute respiratory syndrome, coronavirus 2, etc. In this way, even if some documents do not directly use the word coronavirus, but contain these related terms, they can still be found in the search. This is the basic principle of query expansion. By intelligently adding related terms to improve the coverage and accuracy of the search. Traditional query expansion techniques mainly rely on four methods. The first is a manually compiled thesaurus, like an electronic version of a synonym dictionary. The second is automatically mining related words from massive texts by analyzing co-occurrence relationships between words. The third is analyzing user search logs to identify words that people often search for together. The fourth is learning based on user feedback, optimizing related words according to users' actual usage. Speaking of this, you might ask, in today's era where embedding technology is already very mature, why do we still need query expansion? This is a good question. Theoretically, a good text embedding model should be able to automatically understand and match synonyms and related words. But the reality is not so ideal. Even the most advanced embedding models today may show bias when dealing with ambiguous word meanings. For example, when you search for the medical term skin rash, the model might incorrectly match to completely unrelated content like behaving rashly, because they contain similar words. This is why we still need query expansion techniques. In this case, the large language model, LLM, can leverage its three unique advantages. First, LLMs have a rich vocabulary knowledge base. Through training on massive amounts of text, it accumulates professional terminology and synonyms from various fields. For example, in the medical field, it understands that gamma globulin and immunoglobulin refer to the same concept. Secondly, LLM has the ability to understand and judge word meanings. It doesn't simply perform literal matching, but can understand the meaning of words in different contexts. For example, with the word apple, it can determine whether it refers to the fruit or the tech company based on context. Third, through designing appropriate prompts, we can guide LLMs to generate different types of expanded terms, which can be either technical terms or colloquial expressions, making query expansion better adapted to different scenarios. Gina AI's research team conducted experiments using Google's Gemini 2.0 Flash model, testing two embedding models, Gina embeddings V3 and all, Mini-LM L6 V2, a smaller model. Experimental results show that query expansion can indeed improve retrieval performance, particularly for smaller models like all Mini-LM L6 V2. The average improvement can reach 5 to 6 percentage points. Even for better performing Gina embeddings V3, it can achieve a 1 to 1.5 percentage point improvement. However, this technology also has some trade-offs. First is the cost issue. Calling LLMs will increase system latency and computational overhead. For some application scenarios with high real-time requirements, it may be necessary to evaluate the cost-benefit ratio. Next is the challenge of prompt engineering. Research has found that prompt templates optimized for specific domains often yield better results. This means that in practical applications, it may be necessary to repeatedly debug prompts for different scenarios. The third is the control of the number of expanded words. Experiments show that more expanded words are not always better. For Gina embeddings V3, The optimal number of expanded words is between 100-150, while for all Mini-LM L6 V2, it's around 100. Adding too many expanded words will actually decrease retrieval quality. This research is still ongoing. The research team is exploring several future directions. First, the use of terminology enhancement in document embedding, which may make the document representation more comprehensive. Second, they plan to apply query expansion techniques to other search technologies such as re-ranking to further improve search effectiveness. Additionally, the team is considering developing a language model specifically for query expansion, which may be more suitable for this task than a general model. Finally, they hope to optimize the quality assessment mechanism for expansion terms to better filter out truly valuable expansion terms. Overall, this study shows that there is still great potential in combining traditional search technologies with new AI technologies. That be why properly utilizing query expansion, we can make search systems smarter without replacing existing embedding models. That's all for this episode. If you found it helpful, please like and follow. See you in the next episode.